This video is the second in a series of 3 which explains how Accanto StratOSS achieves 100% service lifecycle automation for next-generation services. In this edition, we will demonstrate how service behavior-driven testing capabilities that are part of StratOSS fully automate testing and significantly reduce operational errors for network services. In order to explain where this part fits, let's recap on what we're trying to achieve overall. The amount of manual effort in operating complex network services increases exponentially with the use of traditional OSS systems. Automation of the operational lifecycle, not just the onboarding and design, has become essential to make the model commercially viable. The greater the operational automation, the more efficiencies. Once live, the operational maintenance of a service is proportionally the largest percentage of the cost and effort. It is here where StratOSS outperforms traditional OSS, reducing manual effort 30 times more than with traditional systems. There are 3 elements required to achieve 100% operational automation. First, intent-driven orchestration fully automates the operational lifecycle of a service without the requirement of manually scripting program code. This offers a cost reduction not only in manual labor, but also in the level of skill required. Second, integrated DevOps-enabled service behavior testing reduces the number of errors in services before they go into production. Fewer errors means less manual effort to diagnose and resolve issues. StratOSS fully automates the spinning up of test or pre-production environments, instantiating services, and necessary monitoring and test resources before running automated tests that run through the full service lifecycle. Third, AI-powered diagnostics. On achieving 80% operational automation through the use of intent-driven orchestration and integrated service behavior testing, production errors may still occur. Artificial intelligence can then be used to automatically diagnose and resolve issues that would normally require human effort. In part 1 of this series, we have shown that StratOSS and its intent-driven orchestration fully automates and productizes the operational lifecycle of network services. In order to further reduce operational errors and decrease manual effort that is required, network services should be automatically and continuously tested as part of a continuous integration process. StratOSS integrates with tools such as GitLab for storing and versioning code and Jenkins for continuous building of the software. As part of this continuous integration pipeline, StratOSS includes a service behavior-driven testing solution that allows each service and VNF to run through its entire lifecycle automatically. For example, once a VNF developer makes a change, this gets committed to GitLab, which then produces a software build process in Jenkins. At the end of this build process, StratOSS then automatically executes the VNF or a full service test. StratOSS Intent Engine automatically spins up a test environment, instantiates the VNFs that are part of the network service, installs probes or other test resources, and then executes the tests. Once completed, all results are logged, the test environment is cleaned, and the build is marked as ready for deployment. This whole process would normally require a huge amount of manual effort, and with StratOSS now can be fully automated. The same test can also be run as a ready for service test to check that the service is working once it has been instantiated in the production environment. This continuous and automated testing reduces operational errors once the service is in production and reduces the amount of manual effort, as all of this is automated by StratOSS. So let's demonstrate how this unique functionality works in StratOSS. Here we see our integrated CI/CD environment where we use GitLab as our third-party repository and marketplace for all the network services and VNF packages. As an example, we can open up one of the network services and see how it is structured. We can take a look at the descriptor file that is created by the network service designer, which defines which VNFs belong to this network service, their relationships, dependencies, and additional items like policies for scaling. In addition, we have enhanced the standard-based service definition with scenarios. These scenarios are specified as part of the design process and function as the basis for automated service testing and diagnostics. These scenarios are created by a drag-and-drop user interface that we will see later on in the demo. Next, let's build the network service from Jenkins. The build can be triggered automatically if a new software version of a VNF is added to the network service or if another change is made. In this case, we will start the build manually. It is now checking out the required components and packaging and onboarding the packages to StratOSS. Once the onboarding is complete, the Service Behaviour Driven scenario is run. As part of the continuous integration process, StratOSS will automatically execute this scenario that runs through a full set of service tests of the voice service. In order to test the voice network service, it needs to be instantiated, which you can see happening here. It can also spin up an entire development environment first in any cloud or local infrastructure. The intent engine brings the voice service into an active state. As part of this scenario, in order to test the network service, StratOSS also instantiates additional test resources, such as traffic generators and probes, that place calls and collect metrics to determine if the network service is working. Once the service and the monitoring resources are in the active state, the scenario continues with the ready for service test. The scenario continues to execute once everything has been instantiated, and it will automatically run through a full set of tests to verify the service behavior. This scenario only includes a few voice tests, but when you're designing the test scenario, there are a wide range of test cases that can be selected by simply drag and drop these into the designer. As part of this test, the traffic generator is now placing calls through the system and metrics are reported back to Kafka. StratOSS monitors Kafka for these metrics and can display related graphs, as you can see here. It shows the amount of calls that have been successfully placed through the system. The test cases are passed, and once complete, StratOSS will uninstall the network service and mark that the service has been tested successfully and is ready for deployment. With the StratOSS Service Behavior Driven testing, customers can automate the entire pipeline, including the testing, hereby reducing the amount of operational errors in services that go into production. As a conclusion, in order to create commercially viable NFV solutions, the traditional OSS systems do not provide enough automation. In order to significantly lower the operational costs for NFV services, a much higher degree of automation is required. 3 elements are needed for this: intent-based orchestration that enforces brutal automation of the entire lifecycle of these services to remove manual effort in designing and especially in operating the services; an inbuilt service behavior-driven test to fully automate service testing and reduce the amount of errors of services that go into production; and thirdly, when things do go wrong, AI can be used to trigger diagnostics and automatically resolve issues. These 3 elements combined in StratOSS enable a significant operational automation and have been shown to deliver over 30 times more operational efficiency than traditional OSS systems.